Hi everyone, in this tutorial I'll answer this question from the Robotics Stack Exchange. This person wants to know if there's a way to use parallel callback instances to process images that are being received faster than they can be processed. I'll show you how to use multi-threading in ROS2 to execute multiple instances of a callback simultaneously to produce any type of received data in parallel. Ideally, you should already have an understanding of publishers, subscribers, and callback functions. I'll be using the constructs ROS Development Studio and a ROS2 onboard workspace called ROS2_WS. Before we start, I'd like to clarify that this may not be the best way to handle the problem of when the rate of data received is faster than the time spent in the callback function, as it depends on the specifics of the application. It is usually recommended to keep callbacks as fast and simple as possible and to feed your data to your classes rather than do all processing in the callback. However, the concepts in this tutorial are useful to know and worth understanding still. I'll first create a ROS2 Python package with a simple publisher and subscriber. This package will be called multi-threaded PyPKG. Then I'll specify the directory as a Python package by creating an empty init file. Then I'll add Python subscriber and publisher nodes called minimal sub and minimal pub. In minimal pub, I'll add a minimal implementation of a publisher. In here, I publish hello world 1, hello world 2, and so on every half a second using a timer callback, incrementing the number by 1 each time. Here, we use the string data type for simplicity, but it could easily be in an image from a camera or any other data type. Similarly, in my subscriber node, I'm also going to put a minimal implementation, and I'm receiving the sent messages and printing them out. Now it's important to note that it sleeps for 2 seconds in each callback. This is in order to simulate processing the data inside the callback. Can you guess as to what will happen when we launch the publisher and subscriber? Before that though, we'll have to configure the package by modifying the setup.py. Specifically, we'll have to add in the entry points. Once that's done, we'll compile the package. And run the subscriber first. And then the publisher. Now let's have a look at what's happening over on the subscriber. So, as expected, the data is delayed, but we are missing a few messages as well. 4, 5, 6, 8, 9, 10. This is because the queue is overfilling and we lose data as well. Not all published messages are shown on the subscriber's side. To fix this by way of multi-threading, we need to understand a little bit about executors and callback groups. Now, an executor in ROS2 uses one or more threads of the underlying operating system to invoke callbacks on incoming messages and events. In particular, a single-threaded executor executes callbacks in a single thread one at a time, and thus the previous callback must always finish before a new one can begin. A multi-threaded executor, on the other hand, is capable of executing several callbacks simultaneously. ROS2 nodes invoke the single-threaded executor when using rcopy spin.spin. Thus, if we want to execute multiple callbacks simultaneously, we will need to use the multi-threaded executor instead of rcl.py.spin. Now, onto callback groups. ROS2 nodes have two different types. The first is reentrant callback groups, where callbacks that are part of this group may be executed in parallel. Mutually exclusive callback groups are where callbacks of this group must not be executed in parallel. Topic subscribers, timers, service servers, action servers all have an argument where you can set the callback group their callbacks will be in. If nothing is specified, as it is in this subscription, their callbacks will be assigned to the default mutually exclusive callback group from the node. So to fix this issue using multi-threading, we'll need to add a multi-threaded executor with the subscription callback in a reentrant callback group. So I'll replace the code in this minimal sub.py with the following. I'll add multi-threaded executor and reentrant callback group, and instantiate the reentrant callback group, and then add the callback group as an argument in the subscription. And then in the main function, I'll instantiate the executor, add the node, and then use it to spin instead of the rcl.py. So now I'll compile the package and see the results. Run the subscriber, remembering to source the setup.bash, and the publisher. So let's have a look over at the subscriber. Indeed, this means it's successful as it's mirroring the publisher. That's because we are indeed running multiple instances of the subscriber callback in parallel. Thank you.